Hi, everyone. It's a pleasure for me, together with my colleague, I'm David Hock, Director of Research at InfoSim. It's a pleasure for me, together with my colleague Simon Schad, to present today about the latest news, what we are doing in the Innovation Lab and what we've been doing in the last few months since the last customer workshop. And to that end, we will actually dive a little bit into the topics. On the first slide here is just a recap of what Stefan Köhler showed not long time ago in the keynote. The StableNet Innovation Lab has quite a large variety of topics we are looking at, and we've been officially starting that work, we've officially started calling it a StableNet Innovation Lab roughly 2.5 years ago. Of course, we've been working together with customers and partners before that. But it's been roughly 2.5 years that we branded it that way. And we are really happy that this is moving forward a lot. This is driving really further the cooperation, starting from very early idea phase up to running pilots together in customer environments and trying out things just to get an understanding on where technology could be going and what is possible. And on the next slide, we just have here a new visualization of some things that might be clear already, but we tried visualizing it in a new way to give an even better understanding what are possible levels of engagement for all of you, basically, for customers being here in the call, for maybe partners joining us today. What could be the cooperation possibilities if you are not part of any of those already now? The first level of engagement is very, very easy, I would say, very simple, not demanding that much of a consistent commitment over time. It's just like basically being available for an exchange. Let it be in a Q&A session of an event like today, or let it maybe better scheduling a joint meeting for 60 minutes, 90 minutes, diving into a general overview of the StableNet Innovation Lab and discussing some of the topics, and really not so much focusing on presentation, but more focusing on open discussion, finding out what are the topics you are looking at, what your management wants you to look at, what is driving your business, or where do you see the future moving for you specifically. So this could be about all of the topics, and we really had plenty of those meetings with different customers and enjoyed it a lot. So if you have not been part of that, or you haven't been part of that for a long while, then please reach out to us. We are definitely available for that and would like to keep going with this. The next thing is we've already quite a number of customers right now that have established with us more regular exchange meetings. So this is like basically the next stage. It's not just meeting on demand for a single time, but it's more like scheduling a monthly meeting, a quarterly meeting, a bi-monthly meeting, whatever makes most sense for the given point in time. And there we are really identifying specific topics. For instance, we have I think I can name that here because we have been giving a joint presentation at the Fiber Days together with 1&1 Versatel this year about some sustainability topics we are looking at together. For instance, with 1&1 Versatel, we have monthly meetings looking in these sustainability topics and sometimes also into other related topics. Or I can also name MTN. MTM and us, we have been working on a joint TM Forum Catalyst, and there is a plan to work on another one next year in 2026. So there also we have regular exchange meetings to follow up on these topics. And last but not least, there is what we recently launched with the release 25 end of last year, what we call a customer pilot program. This is basically going beyond just meetings and general exchange. This is really hands-on. Customers trying out our intermediate results, our proof of concepts, either in their test bed or providing us in a given framework, making sure that everything is done the right way, exchanging data with us so that we can apply our proof of concepts to their data. And most of the time it's actually running in the customer environment, so the data never leaves the company, but our tools are going to the customer in this case. And this is really cool for us because it gives us a lot of insights, but I think it's also very fruitful for the customers because they have a possibility really to try out the opportunities, but also the challenges of new technologies. Marius just mentioned in his talk that AI is a two-sided sword. It is sometimes very powerful and very promising. On the other side, sometimes it's completely rubbish what it's getting out of it. So I think trying this out yourself is also very fruitful for both sides. And with this, we now want to dive a little bit into the specific topics of this talk. And it's a pleasure for me again to hand over first to my colleague Simon, who will guide you through the sustainability and energy efficiency part of this presentation. And then I will take back over for the AI part. Thank you very much.
Then thank you, David, for handing over, and also welcome from my side. And I'm going to guide you a little bit into the topic of sustainability and energy efficiency. And I'll start with a small high-level overview of these topics, which follows some slides which were repurposed from the University of Würzburg, especially Professor Tobias Hosfeld, with whom we are working with quite regularly in many different research projects. And we want to start with a little overview of the trends in energy demand, especially in data centers over the years. If you look at the data from 2023 and also the projection here on the right, 2030, we see there's quite a increase. If you look only at the x-axis of these visualizations, then you see already there's a huge increase in energy demand only in the data centers, not only in the US and not only the AI part, but also in other regions worldwide. And question is this only an increase in energy demand, or is this also the workload itself which is increased? So does it increase somehow the value? And for this, we actually try to answer the question: how do we actually quantify energy efficiency? Because this is very important in this kind of topic. And to this end, Tobias Hosfeld and his team compiled this comprehensive list of different energy efficiency metrics, which include absolute measures like energy intensity as probably most prominent, but also relative measures, with respect to the whole system, but also relative measures in comparison to an ideal reference systems. And this begs the question now, there are quite a lot of metrics which you can choose from. So which are the correct ones in each scenario? And typically this is quite individual for each purpose. So this is not something we can easily generalize. And give you one little example. We look at, for example, the energy intensity of a system. So let's say this is 10 kilowatt hours per 1 terabyte. So now is the question, what is the energy consumption for 2 terabytes? Naively, you would think, okay, it's just twice the energy consumption, but this would imply that you need twice the number of devices and have to double everything in your whole system just to get the 2 terabytes of data from A to B. So this is unrealistic. So the realistic answer is we just don't know. So this is this hopefully clarifies why it's so important to monitor and visualize all of these energy relevant metrics. But sustainability as itself is a little bit more than just energy efficiency. So there's the energy part, which is mostly covered in the footprint, the overall goal in sustainability is to reduce your carbon footprint, so also reduce your energy consumption to reach this or get to this goal. But something which is often overlooked, but is also equally important, is which is called the ecological handprint, is something which can actually basically it describes how ICT communication can actually support other parts of industry and academia in order to achieve sustainability goals. And there was a recent study by Bitkom where they analyzed or the potential for the carbon footprints. So they estimated 2 to 4 million tons of CO2 for digital technologies alone, but also 6 to 11 million tons of CO2 with the production disposal. But on the other side, they estimated a net saving of roughly 40 to 80 million tons of CO2 just by including new kinds of technologies like smart grids, smart homes, automation, also some parts of AI. So this is something we actually need to consider when we look at sustainability in total for the ICT sector. And we can summarize this basically by saying what we actually need in this kind of area is just innovations. We need, first of all, we need a complete overview of different components to systems. We need to know how much energy do we consume, how much power do we consume, but also we need optimization. We need to optimize many different processes, devices, and so on. But also we have to evaluate the handprint and the footprint of our systems in total. And of course, there are some kind of technologies which will enable this or will hopefully help us in achieving some of these sustainability goals. And AI is one of the big time players, obviously, trying to increase automation, monitoring, but also control and decision making. And of course, one of the most important parts also for us is the streamlined emissions tracking. So we have a complete overview of all of these emissions. And last but not least, we also need, of course, people, really talented engineers, computer science, and all other kinds of very much involved people, and also the individual needs from industry, so the insight from either you customers or other partners and research colleagues to get these ideas and also these research topics into the public. Then this was the high-level overview. Let's have a little look at what we are doing here at Infosim in detail. And we'll start by this picture, where we just show you a complete overview of all of the sustainability topics we are covering right now. I have grayed out 2 of these because we already presented these last year. So I want to show you just the rest of them, covering the different scales we have in terms of sustainability research. And we'll start with the smallest one we have in mind for you. And this is this stems from a study or a measurement study the University of Würzburg performed with a network switch. So basically, they took a switch, put them in this climate chamber, ramped up the temperature, and then measured all of the parameters. So in this case, for example, the fan speed, we see, of course, if the temperature increases, the fan will also try to ramp up its speed in a different way at different times or different temperatures. And from this, we can also then measure the effect it has on the real power consumption of this network switch. And we saw this was quite the actual jump here from almost 26 to 35 watts, which is quite substantial compared to other influences of such a network switch. And the fun part about this is something like this. So the connection between the fan speed and the power consumption of a switch is easily something we can basically monitor or look at in StableNet, because so many of these devices already cover fan speed measurements, like you see here on the right side, for the different fans they have in this particular device. And if we calculate the power consumption for together with our partner or our research partner, SYK, which is a local service provider in the area of Coburg, we calculated the power consumption or the energy consumption for roughly 6 months of data and for 63 devices and summarized all of these results here in these two figures, where we look at the energy per fan for each device, or for each device type, and also the total energy for all of the devices we have in this system. And we see here for all of the devices, for example, you see this is. Let's look at we generated 3 scenarios. So the best case, the average case, and worst case scenario. In the worst case scenario, for example, you get here already 400 kilowatt hours of energy just for the 15 devices we have here running with a high fan speed over 6 months of time. In total, this is roughly all of these roughly add up to a one-person household just for running the ventilation of your network switches. So there's nothing else involved. It's not the complete power of the switches. It's only the ventilation of the switch itself. And if you go up the power scale, or the scale of our power measurements, we find ourselves with a little experiment we did at the InfoSim headquarters, where we analyzed the power consumption of access points, Wi-Fi access points here in our building. And this is something which is easily done with StableNet using the correct object IDs. We can just simply measure using power over or Ethernet measurements. We can simply measure all of the different power consumptions for each access point. And more importantly, probably due to the rise of AI, is the NVIDIA GPU measurement, for which we actually built a custom GNMI server, which uses the new telemetry module of StableNet to then visualize the power consumption of the utilization and the power consumption of a NVIDIA GPU. And you see here, for example, in blue, you see the power draw of the GPU versus the utilization. You see they nearly perfectly align with each other. So it's quite obvious that there's some kind of perfect correlation between power consumption and also utilization. For the access point measurements or PoE measurements, this is not so obvious. So we performed some kind of experiment where we just artificially ramped up the traffic, so basically the bitrate over time, to measure how does it actually increase, or how does it affect the power consumption of our device. And we see if we look at the overall graphic, or the overall compilation of the data, we see there is some kind of linear relationship between the two, so between the traffic and also the power consumption of the access point. Now, if you want to go even further in our scale, we'll have a look at one of our customer pilots we put together with 1&1 Versatel, which is something we also already presented at the Breco Fiber Days earlier this year. And it's all about the monitoring of edge data centers throughout Germany. And they have a lot of these data centers which collect quite the large amount of different data, which mainly comes from these air conditioning units, but also from these DC power supply units. And we provided, or we together we built a small proof of concept about how we can actually measure, or how can we compile all of these data points into something which is useful again then afterwards for our partners, our customers, to analyze and decide what to do with all of these devices and locations. And for example, here you can see an individual overview of all of the of these data centers, where you can choose actually where which data center you want to have a look at. You can look at the average power consumption. You can look at the power consumption according to vendor information, but also the energy consumption of your complete location. Also, we included some kind of traffic information, but also the power information, so you can easily see if there is some kind of relationship between the two. Then also important is information about the temperatures. You want to know what is the hot aisle temperature, cold aisle temperature, outside temperature, and so on. So you want to know if there is some kind of fault in the system, and this helps you achieve your goals. And finally, for the last graph, you have also the correlation between temperature and power inside such a data center. We also included an anonymized version of the devices we have in this data center, just to get the full overview, because each of one of these is quite individual and not necessarily the same as the other. But we also wanted to have a look at all of these data centers together. And when we do this, we can just visualize this on the map, see where do we actually consume most of our energy. These are mostly the same in most cases, so there's not a lot of difference. We can also view this in a tabular style. So we look at the energy consumption in I think it's February this year, but also the cost during that month for each of these locations, and also then
maybe to make just a comment before we go into details. These are simulated data and not real data, but the principles should be clear. So just to want to highlight it, that's mentioning in the corner. To make clear that this data is possible to show, but it will be your data, and this data is anonymized, and some changes are done.
This is totally true, and thank you for that, Stefan. So this is anonymized data. So this is not the real business data. But it would look like this. So you see the energy consumption, the total energy consumption, the total cost, and also the changes to the costs and energy consumption to the previous month. So with this, we've concluded the second largest sale. And if we go even further on this, we'll have a look at large-scale global topologies. And to this end, I want to just highlight something we did in another research project where we developed a topology generator, which allows us to develop realistic network topologies for different countries, or basically on any type of polygon on a map. And here we see, for example, a topology for Germany, France, Italy, Egypt, Japan, and Indonesia. And if you look even further down zoom even further down into these topologies, you see there is some kind of information about the population density in there. So this is highly customized to basically the population of each and every country in this world. And this is also something we presented at a conference a few months ago at NetSys, just to highlight this. But this is the basis we use for another sustainability topic, where we want to basically augment these topologies with sustainability metrics. And for this, we built this complete network hierarchy. So based on traffic estimations, we estimate how many number of devices do we need for each of these locations. So each and every node you can see here on this map has a different number of devices per location. So each of these uses different amount of energy. But also, what about critical infrastructure? This is something we investigated also for the TM Forum Catalyst earlier this year, where we looked at all of the devices or all of these locations we actually need, for example, to provide communication towards, in this case, hospitals. So you see here these gray dots, for example, they are not connected to the network, or they're not relevant for any of the hospitals in the area, only the ones which are actually colored in this map. And last but not least, of course, the sustainability metrics themselves. So we estimate or calculate the CO2 emissions, the total energy, and also power of all of these locations and all of these devices we have in these locations, to give you this complete overview of what it looks like in terms of sustainability for such a with such a huge topology. And this is something we are gonna improve further and further throughout the course of the next 2 years in one of our big flagship projects, StableNet Advance, and hopefully show you even more of these throughout the next years. And with this, as long as we don't include any communication to the moon or other planets, I think we cannot increase the scale even more on this. So I think I'll finish on this note and hand over to David again, which will tell you a little bit about the AI research we do at InfoStim.
Thank you, Simon. And I'll get back to this as well at the end, but just as an intermediate comment, if any of the things you've seen so far on the sustainability is specifically relevant to you, then please, of course, reach out to us and maybe become part of one of these pilots as well, or have an individual meeting with us or some discussion. Okay, now let's look at the second part of the content we have prepared for today to give you an overview. This is all about AI research that is currently happening. And we are roughly separating this into 2 parts here for the presentation today. There is an update on time series analysis and also an update on all things related to generative AI that we are looking at. And I will first now on the next few slides start with the time series analysis. This has been a large topic, as you know, already in the last few years. And we are happy that this is still moving forward. We have more customers joining us in the pilot phase, looking into different data. And one of the things that we want to highlight today as a topic that has been with us for a while now is about capacity planning at scale. So here we are not so much looking, or actually not at all anymore, looking into just single time series, but we are really focusing on large sets of time series and being able to do forecasting if we have large data sets, to find the right ones to look at, to be able to handle that these large number of sets and to still use this for smarter, timely capacity expansions, as it says here. And to find an adequate approach to prioritize what needs to be done first. And to that end, on the following slides, we will be showing some data, which is again not coming from a real customer, but which is realistically created in a synthetic way to resemble the real data that we know from the customer. So what I'm showing now on the next slide is actually not the real data, but it's close to the real data. It's similar to the real data to explain what we are looking at. And what we are actually seeing here is imagine that you have thousands of measurements in StableNet. In this case, we are just looking at more than 1,000, but it could be also, of course, much larger numbers than this. And what you actually cannot do anymore than if you have so many measurements is you cannot just constantly run a forecast on each single of your time series all the time continuously, because this would end up in a system maybe wasting a lot of energy and basically running 24/7 just to do a time series analysis. Just if it's very efficient, it's just the number of scales that won't work anymore. So what we need here is an approach to cluster these data sets in an adequate way, to rather than doing individual time series analysis for each single measurement, to do this on a set of clusters. So it's like, imagine like grouping pictures of people on a smartphone to have all the pictures of the same person in the same cluster. What we are doing here is we are chunking the time series into smaller sets, for instance, weekly chunks or daily chunks. And we are putting all time series together that have a similar behavior in this chunk that we are looking at. And you can see this here, I think, visually on that slide. If you look at the different clusters, you can see that each of the cluster has a different pattern that you can recognize. Sometimes there's no peak at all. Sometimes there is just one peak at a different time of the time series of the window in each of these pictures. And what you also can see is that we have a lot of tiny small black lines, and we have a solid red line, which is representing a centroid. So this is basically the average over all the different time series that have been clustered in that box. And what this clustering actually helps us, that rather than having to do a continuous time series analysis of more than 1,000 measurements, here we have just 2 times 10, 20 clusters in total. And we are rather doing just 20 time series analysis per calculation. And here the highlighted one on the next slide, we will now dive into this. So let's look at this one. We see that it's increasing. There is a forecast that it might be exceeding some value. And now on the next slide, what we see is that this time series is actually being split up on the individual time series now. So this is the point where we are getting back again to the individual time series. You have here some, based on the titles of the graphs, you see that those are references to individual synthetic devices that we are looking at, and more specifically not devices, but interfaces. And we just have now 3 different interface measurements, which visually are similar to each other if you look at it. But if you look now on the left side on the Y scale, you see that the red line for 90% is exceeded on the top time series. It will be exceeding that red line according to the forecast. In the middle one, it will be touching it, let's say, mid of next year, most probably, according to the forecast. And on the lower time series, it will maybe reach it, but it's not really, at least according to the forecast, we are not expecting it to regularly pass it. So now this gives us a possibility to do a twofold approach. The first one is to identify this cluster. This is what we did on the previous slide. And now in the second step, we can actually do the individual measurements and find out what are really the risky components that might have to be extended in terms of capacity. It's like basically in the COVID times, they have been testing the whole school class if any of the kids was positive by measuring them all together. And if the overall test for the whole class was positive, then they started to test the individual kids to find who is actually potentially having COVID. Whereas when the whole class was negative, there was no need to test each individual kid because by the way of the approach, there was no need to do this. And it's the same here. If the entire cluster is not risky at exceeding, we skip the cluster. We don't do a detailed analysis. And again, if the cluster is potentially exceeding the threshold in the future, then we can do this deep dive. And this is ongoing work. As I said, we are doing this with customers already on the customer data, which is similar to this synthetic data that we show here. But we definitely have more capacity also to do similar things with other customers. And we would be really happy to continue this work together. Now let's look at the next part here. This is a quick recap on StableChat, like a working title that we came up with during the last 2 customer workshops, 23 and 24. And here we have like the version of 24. And what we have, just as a quick recap, what we basically were looking at is we used whatever was available back then in terms of Gen AI technology and models and in large language models to look what could be possible to talk with a chatbot-like system, to interact with StableNet, to maybe open a weather map, to open a report, to open some kind of a dashboard, or also maybe to get some alarms of StableNet. And it was mainly on this like trying out, getting an understanding where the technology is standing. We saw some things working quite well, but we also saw some other things being completely rubbish at that time still. And we just got to know the limitations. And in general, if we look at the next slide, what we can say is that we were approaching this whole StableChat topic more from an, as we wrote it here, from an initial design philosophy to include as many features as possible in a framework to try out what is generally possible, not so much looking into any kind of performance in any kind of large scalability of the code. We were just trying things out, not so much looking into data protection. And now what we did in the since the last time, what I want to be reporting a little bit about today is we now started to look more into individual use cases. And rather than following up just one single StableChat project as a whole, we separated it into different challenges that we continue working on at this point. And namely, those are 4 things that we picked here. The one thing is a template generator. So it's basically considering StableNet as a potential help with writing XML templates, for instance, for external measurements. Imagine you have a CSV file and you need to create a template in XML that describes all the different metrics that you want to measure. The idea here would be, how can a generative AI help to generate this XML, which has a fixed format according to an XML scheme, for instance. We have the tech filter translator, which is a little bit similar to what also our development team is looking at in parallel for the upcoming releases, not for 26, as Mario said, but for the future releases to come in the next years, how this can be included to translate natural language into tech filters, because tech filters are a powerful thing in StableNet. And if someone is not so skilled or not so trained in doing tech filter queries in a complex way, then maybe large language models could help to write this in a more simple natural language and still generate a good query that can be used. The next thing is the wish of having some kind of documentation assistant, as mentioned here on the lower left. This is basically the idea of, rather than opening a PDF file and searching the PDF file yourself for the right answer, it's basically the wish to just pose your question and the generative AI helping you to find the right spot in the documentation right away, or also maybe linking different chapters of the documentation. And last but not least, we have the REST API connector, which is basically the REST API is getting more and more functions being added. So it's by its nature getting more and more complex when more functions are being added. And we want to look at how people could be supported in working easier with the REST API, for instance, using something like Model Context Protocol, which has been quite promising recently. And now, looking at the next slide, there's a little bit of Pareto paradox, I would say. I believe all of you know the Pareto principle, which is basically saying that you can do 80% of the work with 20% of the effort. And in the AI case, this is leading to a little paradox, in my opinion, or in our opinion as a team, because you can basically, for all of the things that I just mentioned, you can grab ChatGPT, Gemini, any openly available model, and you can just say, okay, I want to generate templates. So I take the PDF of the StableNet documentation, I throw it into ChatGPT, I take the XML scheme, or maybe an example that I wrote before by hand of a measurement template, I throw it into this tool, and the answer that I will get is probably not 100% perfect, but it's 80% correct, in the sense that if I am a skilled user and I know what I'm doing, I can save some time and I can do the rest myself. And the same is for documentation. If I throw in the documentation and I ask a question and I'm not expecting a fully correct answer, but I'm just expecting some kind of a good hint where to look further, then I get along quite long, but still the answer is probably, or in most of the cases when we try it out, it's not completely correct. So it's a high risk to just use it as is. So it's more for skilled users. So it saves 80% of the time, but you don't reach the full goal. So next slide, what we want to reach now is we want to tackle these 20%. And to this extent, we want to look at data protection, how to do this locally. There might be things I just don't want to throw into ChatGPT, Gemini, or anything. I want to have them in local models. We look into validation. How do I make sure that people who are not so skilled or not so trained and don't know how to, if the answer is completely correct or completely wrong or something in between, how can I help them to validate in an automated way that they can move forward with the answer because there has been some verification and check. We are looking into personalization as well. Not all of the answers are generalizable for all the StableNet systems, but some of them might just be specifically for a specific customer. So we need to find a way as well. How can we train a general model, but in the same time include maybe with some RAG system, retrieved augmented generation, or with some information retrieval system? How can we include customer specific things, ideally in a local environment? And on the other side, as a nice to have, of course, we don't want to have any nuclear power plants to run the GPUs and the AI, but we want this to be in a cost-efficient way. So if a customer wants to decide, for instance, to have on-premise artificial intelligence, that they can run this on reasonable hardware investment and not like buying a full server farm with I don't know how many GPUs. And last but not least, also the seamless integration. We also look a little bit into these things like model context protocol, as I mentioned, to look how the integration can be better. And now on the following slides, we just have some examples of ongoing work. The story in a nutshell is that we just see that AI is, I'm repeating my colleague Marius, AI is wonderful in some places, and it's really incredible what it can do. But in some cases, you still see that there is a long way to go. And the whole way how it is working statistically, it's just a statistical machine. So it's not always true. It's sometimes hallucinating, but we are on a good way, at least to work with what we have to move forward. What we have here is some excerpt of the work for local text filter translation, working with local models. To that end, we have written an evaluation tool, which is basically getting training sets of data where we are entering examples for text filter queries and also examples for natural language that is describing this. For instance, on the upper left side, as an example, you have all Cisco devices as a natural language quest. And you have a device vendor equals Cisco as a result. And actually, in this particular result on the left side, you see that it's never green. It's never completely correct, because for those who spotted it, Cisco is written with a lowercase c, but it needs to be written with a capital C for the equal. So this is an easy example. For some other examples here, it's partly green, partly yellow. And this is one of the things we are doing on that end, to have an evaluation framework and to automate the tests so that we can then, in a quicker way, test different local models, do also a performance quantification on with what amount of energy, basically, or with what effort I can use what kind of model to improve my results. And this is well aligned with the work that is being done in the same time, where we are also connecting to things like OpenAI and Gemini and trying the performance of public models. That is probably better because those are large public models running on large infrastructure. But again, it comes with sending the data somewhere outside of the company. The next slide is showing a little bit what we are doing in the documentation, just highlighting some of the challenges we are working at here, and we are discussing also with different people we are working with. If you want to train a large language model with the documentation to get good answers, you have several challenges that are listed on the right side here. First of all, you have to extract the content in a nice way. Is it best to use a PDF for this? Is it best to use an HTML? Is it best to use Markdown or any other format? So those are challenges. You need to chunk it. Do you just chunk it page by page or chapter by chapter? These are all things that are work intensive and not so easy to answer always in the same general way, but it really needs a lot of fine tuning. What embedding model are you using? How are you technically saving all of this and with which database format to link it? So as you can see, there are a lot of challenges we are working on. On the next slide, we see an example. We are making progress, but again, so this is an example asking about updating the StableNet server, what needs to be done. The answer is, let's say the answer is not completely wrong. A lot of these things are definitely right. But if you dive into it really word by word, you will recognize that it might be still incomplete. There might be something missing. The good news is this is moving forward. We are looking into this. The models are getting better. The bad news is it's just like everyone is identifying for AI. It's not a miracle system that is just solving all the problems right away. But we are working on it. And thank you also at this point again to all of you who are working with us together on this and identifying different topics here. Last but not least, the last thing I have on AI is the REST API connector, the model context protocol for an exchange between different agents, which has become more and more relevant with the so-called agentic AI approaches, where different AI agents, not to be mixed up with the StableNet agents, but in this case, we are talking about AI agents, where different AI agents are communicating with each other. The model context protocol has come up as a new exchange format. And we are also looking into this. On the right side, you can see some examples where we basically have just some commands, show me some info about Dallas, Router Lab, InfoSim. And actually in the backend, there's a REST API call being made, the adequate one, the answer is translated into a text. And the same for the coordinates down for the weather station. And what is now the special thing about this is that it's not like a few years back in our Alexa demos that we had, that each single command that you want to have, you have to completely program, and you have to program the question, and you have to program the exact output format. But in this case, you just prepare the model context protocol to get a general understanding of the REST API, but you don't need to specifically stick to a concrete wording, nor for the question, nor is the answer exactly a very concrete wording, but there is flexibility in this. And this obviously offers new possibilities. With that, we are slowly ending. This is just another example, but ending here with basically getting back to the beginning. A lot of what we could show today and what we are working on is based on very, very helpful input that we get from individual meetings with all of you, also from the research projects, of course, that are tackling these activities. But also from the regular exchanges with already a selected group of you who are here today. Also, again, thank you to those people who join us today, who are already doing this with us. And the customer pilot obviously is the highest possibility, like really trying these things out yourself. And I just want to close with this together with Simon and also with the rest of my team in the background. Thanking all of you for the cooperation in the past and for the continued support. And please reach out to us to let's cooperate together. Thank you very much.